You want to know the worst thing about modern truck engines? It's not that they fail. Engines have always failed. It's that when they do fail, the manufacturers are replacing the entire engine and telling you with a straight face that everything's fine. That tells you more than any press release ever will. I spent 3 weeks going through failure reports, lawsuits, and owner complaints about engines from Toyota, GM, and Honda, not fringe brands, not startups, the three names that built their entire reputation on engines that just work. And what I found, it's a pattern every truck owner needs to understand before they sign anything. Here's what most reviewers skip over. I'm not going to. When an engine fails at 11,000 miles and the fix is a brand new engine, that's not a repair. That's evidence something in the design itself can't be fixed any other way, and all three manufacturers are dealing with the same root cause. Toyota recalled over 229,000 Tundra trucks and Lexus models for their 3.4 liter twin turbo V6. The problem? Metal shavings left inside the crankshaft during production. Metal shavings. According to Toyota, these metal fragments stay inside the crankshaft's oil passages, restricting oil flow and causing rough idling, knocking, stalling, or total catastrophic engine seizure while driving. Many owners report issues under 20,000 miles. They literally describe the engine self-destructing. And here's the really uncomfortable part. These defects forced Toyota to recall 2022 through 2024 Tundras, but owners of 2025 models keep reporting failures, which suggests the problem may not be solved. All right, let me be clear. This is Toyota, the brand that made its name on engines that outlast everything. When you buy a Tundra, you're not buying an experiment. You're buying a $60,000 truck that's supposed to work for 20 years. And instead, Toyota admits it still doesn't know how many affected engines actually contain the debris. Right? And for now, they're developing the remedy, which usually means full engine replacement when main bearings are involved. Now let's talk about GM. The lawsuit involving GM's L87 6.2 liter V8 brings together 11 separate cases alleging a manufacturing defect with the crankshaft and connecting rods. The issue can lead to catastrophic engine failure, affecting more than 700,000 trucks and SUVs built between 2021 and 2024. There are 28,102 field reports tied to this problem. Roughly half involve catastrophic failures, causing loss of propulsion. And get this, 42 failures were accompanied by fires, with 12 crashes and 12 injuries tied to engine failure. And that's just the 6.2 liter. GM also faces a class action over their turbocharged 1.2 liter 3-cylinder after plaintiffs experienced violent mechanical breakdowns in their brand new 2024 Chevy Trax. A reduced engine power message flashed across the dashboard, accompanied by loud knocking before the vehicle stalled completely. With just 11,581 miles on the odometer, the dealership delivered the grim news. A broken connecting rod destroyed the engine. Complete replacement needed. The plaintiffs argue GM has known about these issues since 2022, if not earlier. They claim GM was aware the engines were prone to premature internal failure, including bearing and connecting rod damage, oil leakage, loss of propulsion, and fire. So you've got engines at both ends of GM's lineup, small turbocharged 3-cylinders, big V8S, different displacements, different applications, same result. Class action lawsuits allege premature internal engine failures, including bearing damage, connecting rod failures, oil leaks, and loss of propulsion. In the worst cases, total engine failure. And replacement engines are reportedly back-ordered, leaving some owners waiting weeks or months. And Honda Honda built a 50-year reputation on engines that refuse to die, but their 1.5-liter turbocharged four-cylinder makes the list. When it first arrived, the big issue was oil dilution, where fuel contaminated the oil. More recently, head gasket failure, and when the gasket goes, coolant leaks into the combustion chamber and causes severe engine damage. See, the most common problems are oil dilution under certain conditions, carbon buildup on intake valves, fuel injector issues, spark plug failure from carbon buildup, and head gasket failures. The oil dilution issue has been ongoing for years, with a class action lawsuit currently active. Owners allege that 2019 to 2021 CR-V Civic and 2018 to 2021 Accord vehicles experience fuel contamination of engine oil. While this process occurs in every engine, excessive fuel leaking into the oil contributes to engine wear. In Honda's 1.5-liter turbo, oil dilution results in oil level rising, failure of engine bearings and other internal components, which can result in catastrophic engine failure and even stalling while driving. Here's where it gets interesting. All three of these failures have a common thread: turbocharged engines, small displacement, high pressure, direct injection, extreme heat, and oil systems that can't keep up with what the engine's being asked to do. So because of its small displacement and added stress from turbocharging, the Honda 1.5 liter operates under high heat and pressure, and that strain now appears to be catching up with it. So why is this happening? Why are so many automakers suddenly struggling to build modern engines that hold up? The biggest driver is modern emissions and efficiency requirements. The industry made a choice. They decided fuel economy numbers and emissions compliance were more important than long-term durability. And they did it by asking smaller engines to do the work of bigger engines using technology that introduces new failure modes that didn't exist before. Oil-related issues account for more than 90% of turbo failures. And that's not because drivers forget to change their oil. It's because turbocharged engines demand more from motor oil than any other gasoline application. Turbo bearings spin at 150,000 plus revolutions per minute. Oil temperatures reach 450 degrees Fahrenheit in the turbo housing, and there's constant threat of coking that can destroy a turbocharger in seconds. Oil shear rates are 10 times higher than crankshaft bearings. Think about what that actually means. You've got an engine designed to run thinner oil for fuel economy. That oil's being subjected to temperatures and pressures that break it down faster, and the turbocharger itself is spinning at speeds where the oil film between bearings is measured in microns. One contamination event, one moment of oil starvation, one heat soak shutdown after hard driving, and the turbo can seize or shed metal into the oil system, which then circulates through the entire engine. The lower operating temperatures, turbo pressure, and mass amount of fuel pressure that isn't getting burned off is what's causing the bulk of oil dilution in Honda's 1.5 liter turbo. Honda says the problem occurs when the engine doesn't warm up enough to evaporate unburned fuel that slips past piston rings and infiltrates engine oil. The 1.5 liters cooling system is highly efficient, so the engine's slow to reach operating temperature that would cause fuel to evaporate. Short drives in extreme cold make it worse, sometimes resulting in owners reporting oil levels above the full line. So the engine runs cooler for efficiency. The fuel doesn't fully burn. It drips past the rings. It dilutes the oil. The oil loses viscosity, and then the bearings start to fail. This is not a maintenance issue. This is a design that's incompatible with real-world use. Owners also allege that when taking their vehicles to Honda for repair, they're told the level of engine oil dilution is considered normal. As a result, they're denied warranty coverage and forced to pay out of pocket. Now let's talk about what this actually costs you. Replacing a modern engine can cost anywhere from $8,000 to $20,000 depending on the vehicle and labor. And for some drivers, the problem occurred shortly after warranties expired, leaving them responsible for the entire bill. But the bigger cost is time. Even when the recall is covered by the manufacturer, it's often the consumer who pays through breakdowns, towing, and being stranded without a vehicle for weeks or months while parts and replacement engines sit back ordered. Engine replacements can take 12 to 18 hours of labor per vehicle, which overwhelms dealer service departments. I talked to a guy who owns a 2024 Silverado with a 6.2 liter. Engine failed at 18,000 miles. Dealer told him 8 weeks for a replacement, 8 weeks without his truck. He's a contractor. That truck is how he makes money. GM gave him a rental, a compact SUV. He can't tow his equipment with it, can't haul materials. He's paying a truck payment on a vehicle he doesn't have while trying to run a business with a loaner that can't do the work. And that right there is the difference. The real cost of engine failure on a modern truck isn't just the repair, it's the disruption. It's the loss of trust. It's the realization that the truck you bought because it was supposed to be reliable is now sitting at a dealership waiting for parts because the manufacturer can't fix the problem without replacing the entire engine. Nobody at the dealership will tell you this, but here it is. When you're shopping for a truck in 2026, you need to ask a different question, not how much horsepower does it make, not what's the fuel economy. You need to ask how many of these engines have been replaced under warranty and why. Because the manufacturers know, they have the data